Claire, and I'm here with my friend and colleague, Dr. Rainer Viehweger, and we're doing another in our series of introducing ideas of an interscalar worldview. And this is our second video, I believe, in this series. And so, Rainer, it's lovely to see you again. And I know you've got some wonderful information for us. Can you just give me a quick rundown of what we're going to be covering today? What's the sort of focus today?
Yeah, hello Patricia, it's really nice to be together again and to talk about what Hartmut Müller called the interscalar worldview, because he was the one, and that was in the 80s of last century, when he developed a theory that he called global scaling, that describes a phenomenon that we find everywhere in nature, in the whole universe, in microstructures and also in macrostructures, in time, in space, in biology, even in economy, and distribution of people on the different parts of the earth. So there are so many examples, and it's really universal. And it talks about how a harmonious order is created in the whole universe.
Yeah.
And the order comes from a logarithmic scale. So we will talk about the natural logarithmic scale today. And we try to figure out why this is able to create the harmony that we are looking for in the universe. And that implies so much that we need to know for a better future. That implies that it does not only show the inner harmony of the universe, but it also provides the way how everything in the universe is able to communicate and to cooperate. It also gives us the assumption what life is, and it will tell us that the whole universe is a living system, as we have always heard it from ancient cultures.
Yeah, most people kind of don't realize that. They don't understand that fact.
Yes.
That inanimate, so-called inanimate objects like solar systems or planets have a structure and an order and are living and have an intelligence and an order, harmonious order.
I used to explain it in a very simple way. We all know about the bacteria in our gut system. So we may be the bacteria in the solar system.
Oh yes,
in the organism of the solar system.
Good way of putting it. Yes.
And the solar system is just a bacterium in the galaxy.
Yeah, worlds within worlds.
Which implies that things are embedded into each other. Yes,
the embedding, which we did talk about last time a little in our discussion. Yeah,
the embedding. And we will also try to figure out how the genetic code for the universe, which is information, is a number code that is really universal, which is valid everywhere at any time in the universe. It's always the same. So some people say mathematics is the language of the universe, and we can really say that the numbers build everything, because we are using them for counting.
Yes.
And numbers describe different things. So they can describe quantities, but also qualities. So a pair is different from a single in a quality, not only in quantity. And we built the first geometric structures with very simple numbers.
Yes, we do. Yeah.
And we can see the symmetries, and when we can see relationships and energetic processes that relate to each other. They come in ratios.
Okay.
So, and this is embedding again. So we, in a 4 meter distance, we find 1 meter 4 times. So 1 meter is embedded 4 times in a 4 meter distance. Mm-hmm. And this is also how we measure. Mm-hmm. We use a reference, that's the meter, and then we measure distances and say, how often do we find it? And when the distance is longer than a meter, then it's an integer, a multiple. If it's shorter, if it's only 10 centimeters, then it fits 10 times into, and we divide it by 10. So there's a divisibility.
So smaller and larger embedding.
Smaller and larger.
Yeah.
Yeah, and then something may be embedded in the 1 meter, like the 10 centimeters, 10 times. Mm-hmm. Or 1 meter is embedded in a 4 meter distance. And this is how the whole universe works. And it also works with time. A minute is embedded in an hour by 60 times. Mm-hmm. An hour is embedded in a day with 24 times. Mm-hmm, mm-hmm. But, and this is interscalar, when we go from that time scale of 24 hours, which we use in our everyday life, we can turn this easily into the rotation in the of the Earth, because that's 1 circle, 1 turn of the Earth, and we can easily relate it to wavelengths, because I don't know the English word now. The circumference of the Earth, that was the word I was looking for. Yeah. The circumference of the Earth is the wavelengths of that 24 hours. Right.
Yes, I guess it is, yes.
Yeah. This is the distance when we sit in wherever in
wavelength is a distance,
or where I am now, and we wait 24 hours, it seems that we would come back to the same place. We don't, because we are moving in a spiral.
Oh, that's right,
motion. And that's very easy because the sun is also traveling in space.
That's right.
On a very high speed.
Yes.
So our movement is more spiral than simply turning in one place. So it's more like this.
So, yeah, most people don't realize that the sun is also moving, and we're all in motion.
Yeah.
And you have to ask yourself why it doesn't disintegrate. How does it work that we don't? And I think we covered that in the last video a little bit.
Yeah, and we will cover this again today.
Okay.
Because the whole interscalar worldview is showing us how that kind of stability is created in the universe that we can observe, that we can measure. So the universe of space-time. The numbers are beyond that, because space and time are local phenomena. So the numbers, they are every time, everywhere. So they're just beyond space and time.
Yeah. Okay.
And I think it's important that we talk about these things. And I want to mention again Armin Riese, the Swiss philosopher, who learned a lot from the Vedic philosophy. And he says, over the last more than 5,000 years, we lived in a world where we were separated from the source. And that simply means we were separated from the natural way how we would provide ourselves with energy. Because in the last 5,000 years, with all the wars that we had and people taking things away from other people, and stealing things and exploit people and so forth.
Still happening. Yep.
That is still happening, but hopefully changing now. May take some years. But the way how we provide ourselves with energy was different. So the people who exploited others did not tap into the universal energy, because they did not know how to do that. Or you could say, if you talk more spiritual, they were just separated from the light, standing in the dark, but still need that light energy from others who had the light from the source.
That's not just a philosophical concept. It's
spiritual, but it could also be very how can I say that? Very everyday like.
Practical kind of everyday.
That people live on the energies of others.
Yes, they do, don't they?
Yeah.
Yes, I know that.
If we tap into the harmony that is provided through the scale we are talking about today, to the distribution of everything on the scale, we are in communication with the whole universe. And there is an energy and information flow through the different areas of the scale, because we will see there will be big attracting points on the scale, there will be smaller attracting points, and they are all connected to each other by factors, and those factors all relate to the same number at the end. So we will talk about that.
Okay.
And this is the way how we can tap into the universal information field and into all the energy we need. And I call this the universal love, or being connected with the source.
Yes, exactly. Connected to source, yeah.
Which gives us the feeling to be part of everything.
Yeah, part of something bigger than us, yeah.
Yeah. And I think this is very important, how we develop science and economy and how we live together, creativity in the future.
Totally. We need this view, don't we?
Yeah. And from an energetic point of view, it will be much more effective.
Yes. Yes.
Yeah. Because nature has figured out how to do things effectively. There was much more time.
Yes,
to
billions
arrange
of years.
Everything into the right spot.
Yes. Okay. So yeah, connectivity then is the way forward. So
it is. And then we also have to ask the question, who we are and how important we are in the universe. I love that Hartmut Müller always says, we are the eyes and the ears of the universe. It's not only us, because the animals have eyes and ears as well. But as long as we are living, as we said before, living beings in a bigger organism like the solar system, we could also say we are eyes and ears of the sun. But as the sun is, again, an integral part of the galaxy, we could also say we are eyes and ears of the galaxy.
The galaxy, yeah.
Yeah. And it is simply self-exploring.
Tell me what you mean.
It's true that we change locally the universe.
Mm-hmm.
We have an impact on how the Earth looks, of course.
Yes, desperately.
Yeah. And we have the ability to destroy the natural harmony, but we also have the ability to adapt to it and use it for the good of us and for the good of nature. And this is important. And then we can always ask the question, is this what's happening today around us? Is this serving unity and love? Is this serving communication and cooperation? Is this serving connecting to the source? Or is that part of a process that is based on separation? This is a question we can always ask today, and then maybe it's easier for us to see the intent of what people are doing.
Yeah, whether it feels in concordance with connectivity and unity or separation and dissolution.
Yeah. And this is what many other people say, is this love or not?
Yeah, exactly. I often say that, is that what love would do, is the question I use with people.
And that's how we can use this as well in a bigger picture, not only in a simple mathematical or
so it has practical and spiritual philosophical connotations. It's not just about understanding the mathematics, although I know you're going to go into the mathematics because that's the exciting bit, but it has a practical application as well.
Yeah, it has. And then we could come to the next question, which would say, who or what created the universe? Who is the creator, or is there a code behind it? And then we could say the genetic code of the universe is really that number code, which we use for counting, and all the ratios that exist between numbers. So we know that from music. We know the musical harmonies that are octave, which is a ratio of a half. Or and others, thirds, fifths, and so forth.
So
these are ratios. And the Greek have found it.
Pythagorean tuning, I seem to recall.
And we will see later how that important number, Euler's number, is made of this natural harmony.
Yes, it's an extraordinary.
That will be quite interesting. So we could say it is really the number code which arranges, and the number code is information, which arranges the energies. And what I would like to call energy is always an oscillatory process, or a vibration, or the turning of a circle. So it's always something that is in one place and that goes somewhere and then it's coming back.
Yes, that's what you mean.
And then to make it a vibration or an oscillatory process, that kind of movement, it has to be repeated. So you have to do it again and again. And then when we talk about a frequency, and a frequency is simply describing how often do we repeat things in a certain amount of time. When we talk about 10 hertz, that's 10 times in a second.
In a second, yes. Mm-hmm.
Yeah. And there's always also a distance related. So when we have, let's say, a circle, the distance would be the radius. When we have a pendulum, the distance would be to go from the starting point to the end point and coming back to the starting point, which is again a circle. And that is what we call the wavelengths.
Yes.
And then we have another one, which is related to time, just like frequency. And that's the oscillational period. So that's the time that is needed for one circle.
Okay.
And these are things we can use for all kinds of calculations. But what is very important is the repetition.
It has to repeat, yeah.
Because only when we repeat things, we can create memory.
Yes.
If we do something only once, we have not really created a memory. We have to do it a second time to be able to compare it to the first time and realize, oh, that's the same thing.
Of course. Yes, to know it's the same, yes.
Yes, and I think I heard Nassim Haramein talking about it in just the other way around, where he says memory creates time.
Oh, okay.
Yeah, it's only the other way around, because you have to repeat things, and to repeat things you need time. And if you have memory, you would create time, because you have to repeat things a few times.
Yes. Yes, it's just looking at it in
but
reverse.
I think the repetition creates the memory. And the number of the repetitions is the frequency. And again, we are back to numbers. So we can count the repetitions and build on that. And then we know not everything is turning in circles. We talked about the spiral movement of the Earth together with the sun. But when we look at spirals in nature, and things spin, and then the spiral becomes bigger. And bigger. And this is a process that we call scaling. So the circle has to scale up. It has to grow by a factor to create a spiral, always come to the next level. And if the factor is the size of the circle itself, or the number itself, then it's an exponential growth, which is creating a logarithmic scale.
Okay. So that's the factor of growth.
Yeah, because what is the logarithm? The logarithm is the exponent. So if I use a logarithmic scale to the basis of 2, then I would say 2 times 2 times 2 is 2 to the power 3. And 3 would be the logarithm.
Okay, yeah.
So or it's the exponent. So
it's the exponent,
when we use the logarithm, we always look for the exponent.
Yes, it's a shorthand way of
Yes.
calculating large or very small numbers, isn't it?
Right.
Yeah.
Right.
Mm-hmm.
But the law is that there's always something which is multiplied with itself a number of times.
Okay.
That's important.
Something. Okay.
So we are talking about oscillations because they are the most effective type of movement.
Mm-hmm.
If something oscillates, it needs least energy.
Okay, least energy, right.
So if we excite a pendulum, that will start to swing in its natural rhythm. Mm-hmm. The way it likes to do that, with lowest energy. And this is always harmony. That's what we want to know. And this is what we call the natural oscillation. We can go to subatomic particles, and we can look at the frequency of an electron, which is in a textbook, in a physics textbook. This is the natural oscillation of the electron, the eigenvalue of that oscillation. And the same is true for the other stable particle in an atom, that is the proton.
So eigenvalue relates to subatomic particles only, or?
No, it always relates to something that
anything.
is giving the system its identity,
right.
How it likes to be. Yeah, after one excitement, it creates a pattern of oscillation if it is a system.
Okay.
And this is how it likes to oscillate the longest time.
So it's a sort of optimum.
Yeah.
If you like. Yeah.
Yeah. On the lowest energy level.
Lowest energy.
Using least energy, lasting the longest.
And
time.
lasting the longest, yeah. Okay.
Yeah, and that's why those natural oscillations are so important. And then we have a few of those oscillations which are very, very stable in the universe. There are so many, but there are only, basically it's only two that live for a very, very long time.
Yep.
And one of those oscillations is called the proton, and the other one is called the electron. We find them everywhere. They make up all matter. And that's why we can use them as a gauge measure, or we can calibrate our logarithmic scale with the properties of the proton and the electron.
So we can calibrate, okay.
Yeah, we will see that later, how that can be done. Because if we have a frequency, let's say of 5 Hertz, we can create a ratio how often the very fast oscillation of a proton would fit into the 5 Hertz.
Yes.
How often the oscillation of the proton is embedded in the 5 Hertz. For this, we can calculate easily by division. We can easily calculate a number.
Yeah, as long as we know how the proton oscillates. Right. Yeah.
And interestingly, that number is a logarithmic number. So we can take this number and logarithmize it with the natural logarithm with Euler's number E.
Mm-hmm.
And then we will find, and we will come back to that later in an example, and then we will find the exponent, which is a number. And that simply means how often do I need to multiply and that factor is always Euler's number to the power of a number.
Something, yes.
Yeah, that will always be the ratio between, let's say, the 5 hertz and the frequency of the proton.
Mm-hmm. Yeah, okay, I think I get that.
And we can see the embedding again.
Mm-hmm. It's just Euler's number then is a way of representing the scaling.
Yes, you can create scales with all kinds of numbers.
Yes.
But the logarithmic scale on the basis of Euler's number is special, and we will talk about why.
Yeah. Mm-hmm.
Just in a minute.
Mm.
So we can say numbers are symbols for quantities and qualities.
Mm-hmm.
Numbers are real things. So we can say this is 1 meter, this is 2 meters, 3 meters, that we can use for counting. And we can say, and this is an important statement again, the number continuum pre-programs all structures and processes.
Okay, so it creates some sort of order.
Yes.
Yeah.
Yeah.
Mm.
Because they express how things are related to each other.
Mm-hmm.
And because this is universal, that expression of ratios and relationship is so universal. You can compare everything to each other or to other things, and you always use the same numbers.
Wow.
Yeah.
Okay.
And that's why they always pre-program things. And then we will see why Euler's number is such a special number that nature uses for that pre-programming to create stability. And that's why we can also say the origin of life and the universe, if the universe is a living system, is again the number continuum.
Does that imply a creative instinct, or is it just dependent on itself? Is there
the law how stability is created in a harmonious way is again part of the number continuum. It cannot be different. Okay. It's in the numbers themselves, and it's in how numbers relate to each other. Because if numbers are multiples of each other, then they create something that creates what is called destructive resonance.
Okay, yeah.
So if the sun and the Earth orbiting the sun would be in an integer relationship or in a rational relationship of a half, of a third, of something, the whole system would exchange energy in a way that it would destabilize itself and it would be destroyed. It would not be stable. So numbers must find a way to avoid those integers or rational relationships.
Yes. Yes.
And they do it by using numbers that cannot be divided or multiplied with anything and make it rational or integer. And those numbers are called transcendental numbers.
Yes, which Euler is an example.
And Euler's number is a transcendental number. But there are infinite amounts of transcendental numbers. But Euler's number is special. And it seems that there's only one number that exists that has the properties of Euler's number. Because when we create the logarithmic or the exponential function with Euler's number, you can calculate the rate of how that function would change. And in the case of Euler's number, that rate of change, which mathematicians call the derivative, is again Euler's number, which is transcendental.
Yes.
That means not only that Euler's number itself avoids destructive resonance, it is also the rate of change that avoids destructive resonance. So this is the only number in the universe that does this the most.
Yeah.
That's why it is so special. And when we have a scale, a logarithmic scale that says 1, 2, 3, 4, always with the same distance between the numbers. And if we call this the natural logarithmic scale, that would mean e to the power, so Euler's number to the power 1, Euler's number to the power 2, Euler's number to the power 3, and so forth. So the factor of multiplication to get from 1 to 2 is E, is Euler's number.
Right.
Because Euler's number to the power 1 is Euler's number itself.
Yeah, that's...
If I multiply that with itself, I will have E times E, which is E square.
To the 2, yes.
E to the power, to the 2. If I do that again, it will be E cubed, e to the power 3, and so forth. And every time I do this, it will be a transcendental number. Because whatever I do to a transcendental number, it always remains transcendental.
Yeah, that makes it different to an irrational number, doesn't it?
Yeah.
Because you can often multiply, say,
right.
root 2 times root 2 is 2, isn't it?
Yeah.
Is that right? Yeah.
Yeah. Yeah, and that's a rational number, or even a natural number. Yes.
Yeah.
And that can create destructive resonance.
Yes, so we want to avoid that. So nature has found a number that enables it to have multiplied factors that are all transcendental.
Right.
Got it. Right.
And that's the only number in the universe that has these properties.
Which is remarkable.
Which is a remarkable. But it's not only true for the integer powers of Euler's number. It's also true for the rational powers of Euler's number. So, which would say Euler's number to the power 1/2. Which is simply, in other words, the square root of e.
Yes.
Or we can go e to the power 1/3, which is the cube root of e. And we can go to e to the power 1/6, which is the 6th root of Euler's number.
And they're also transcendental, yes.
They are always transcendental.
So and is there an infinite number then?
Oh, yes.
An infinite number of...
And this is what makes this logarithmic scale. We are talking about a density spectrum, which I would like to explain right now.
Yeah, I've not heard that.
So when you have that scale and you have e to the power 0, which is 1, and then e to the power 1, and in between the two, you would have the square root of e. That is e to the power 1/2.
Yes.
And then if you have e to the power 1/3, you go more to e to the power 0 from 1/2.
Yes.
If you have a 4th, you come closer. If you have a 6th, you come closer. If you have a 10th, you come closer. If you have a 12th, you come closer. If you have a 100th, you come closer. If you have a millionth, you come closer. And you can come infinitely close and never reach it and never get there.
Yeah.
And this is what mathematicians call an asymptotic approximation.
Okay, brilliant. I'm gonna
and they also call it a mathematical singularity.
Oh yes.
Yeah, and this is what physicists have their disputes about black holes. Because they say in a black hole they say there is a singularity in it. But then the physicists say in nature you can't have a singularity where there's nothing.
Okay.
You can only have it in mathematics in theory, but in practice you can't have it. So yes, when we go back where we said there are those transcendental numbers coming closer to one single point, that means that the spectrum of where we find transcendental numbers on the scale is denser around
zero.
The integer powers of E.
Ah, okay.
And that means that everywhere where we find, let's say, integer power ratios of integer powers of E, we find attracting areas for stability. And this is how all kinds of real physical processes try to arrange themselves with each other to find the maximum of stability.
Okay.
And of course, between two integers, which are two main attractive points on the scale, we find the square root of E between the two. This is also another attractive area. And also the cube root of E is another one. But those areas are smaller in their attractive force that they can create.
Okay.
So what we have seen now is that there is this Euler's number, which supports avoiding destructive resonance, so provides stability to all kinds of systems. That the distribution of transcendental numbers shows us a spectrum of possibilities how real processes can arrange themselves. And this spectrum is fractal in nature. Because around every integer number of the powers of E, it looks the same. It is self-similar.
Yes.
And logarithmic scales are fundamental in, are fractal in nature in general. And this is why this density spectrum of the distribution of transcendental numbers on the logarithmic scale to the basis of Euler's number is called by Hartmut Müller the fundamental fractal.
Okay.
Because this is how nature over time will arrange everything in a harmonious way with each other to create stability on the lowest energy level that provides longevity.
Yeah.
So if we want to live a long, healthy life, we should try and stick to that harmonious order in our body.
Yes. How do we do that?
How do we do that? Yes, so we can do that on different levels of the scale again. So it's the way of what we think. Precisely. It's the way of how we feel.
Yes, feel.
It's the way what we eat.
Mm-hmm.
It's the way how we try to keep our physical bodies flexible and
mm-hmm. Yes.
Energetic through exercise.
Mm-hmm.
Yeah, so we have certain ways of how we can destroy our bodies. That's bad thoughts, bad feelings, eating the wrong things, not doing exercise, because exercise will charge us, dehydrate, because water is also needed for charge, for energy. And then self-healing is coming from the inner wisdom of the genetic number code of the universe.
Self-healing, wow, okay.
The only thing we have to figure out is what is blocking that natural flow of energy and information in our bodies.
Yes.
And those blocks may be the wrong heavy metals that replace some of our minerals. That may be all chemical substances which occupy the receptors of our hormones for a very long time, stopping our cells from reacting to the environment, to new signals. That can be belief systems, which are creating stress. And with stress, inflammation, so higher energetic levels that we really don't need.
Yeah.
So this is the work we have to do as therapists, for example.
Absolutely, removing the blocks. Yes.
Figure out what's going on and how the human being we are trying to support, how can we help them integrate into the energy and information flow of the universe. So how, in other words, how to help them to put themselves back into loving and into bathing in love.
Yeah. Yeah. Energy and information as kind of the natural state, and love being that expression, if you like. Yeah. Yeah. Beautifully said.
Yes.
I love that view. That's really what we do, but we don't often talk about it.
No, and I think that's the most important thing. And then, of course, everyone can still be different.
Yes.
Because these density spectra are not rigid. Physiology always gives us the opportunity to be on different energy levels, to explore the world and to adapt and react to the environment. We were talking about 5 hertz.
Yeah.
And how that relates to the oscillation of a proton. And if we do the simple math and we divide 5 hertz by the frequency of the proton, we get a number, and that number is e to the power minus 54.
Very small number.
It's a very small number, and it is an integer number. So it's one of the big attractors on the logarithmic scale.
Yes. Okay. So it's the power is a
that provides stability. But what is the 5 hertz? 5 hertz in our nervous system, in our brain waves, for example, is a very important point.
Yes, yes.
Because this is in the theta range.
Theta, yeah.
And this is the range in which we move from being awake to sleep.
So it's that transition.
So everything of brainwaves that is below 5 hertz is related to sleep. And the more we come from theta into alpha, which is higher frequency, and beta, that is being awake. So these attractive areas, those so-called islands of stability, they are not only attractive points, they also mark important boundaries.
Okay, so they mark a boundary, yeah, between something.
We find very interesting boundaries only if we look at the scale of our brainwaves.
Okay.
And between the range of theta and alpha, we find a boundary at the square root of E again. And this, interestingly, is nearly the same frequency that we know as Schumann frequency.
That's about 7.8.
7.83.
3 something, yeah.
And the main attractor is at about 8 hertz. So it's just close to it. Yeah, and we say the alpha wave range in our brain waves goes from 8 to 14 or 13.
Yes.
And we can observe another interesting thing here. From 5 to 8, this is about the square root of E, of Euler's number. From 8 to 13, this is also about the square root of Euler's number.
How can they both be the square root of Euler's number?
If you divide 8 by 5,
oh, right.
This is the value of the square root of E.
I see.
And that is 1.648.
Okay.
And these numbers sound strange, don't they? Don't they sound familiar? 5 and 8, and 8 and 13, and 1.648. Isn't there something?
Yeah, that definitely rings a bell, but
that rings a bell, doesn't it?
They're constants, aren't they?
5 and 8 is a member of the Fibonacci series.
Yes.
8 and 13 is a member of the Fibonacci series.
Of course, which
and
is where...
What is the constant factor in the Fibonacci series? Called the golden ratio.
Golden ratio, right, yes.
So, so what we see here is that in this area of those frequencies and where we find our brain waves,
Mm.
The boundaries follow the steps of the Fibonacci series.
And that can't be.
And the golden ratio. This is very interesting, isn't it?
Yes. Yeah.
Yes. And the Fibonacci series is recursive, which means this is how, and we talked about this in another video, this is how nature creates backups.
Yes, we did.
Yeah, this is how things like to grow, creating a backup instead of exponential growth on the basis of 2, which is always doubling, that we use in technology, for example.
Yes. In computing and so on.
In computing everywhere, we just double things.
Yeah. 64 bits and
and then 128 and 256 and so forth. In the Fibonacci series, it's not the doubling. It's a little bit less than doubling.
1.648.
1.6. Because a few of those things don't double. They are kept as backup. So if something goes wrong in the future, you can go to the backup and start again.
Ingenious.
Which you cannot do if you double everything. And this seems to be a characteristic of tumor growth, of cancer growth.
Oh gosh. So cancer cells double.
They seem to double. They seem to follow that principle much more than normal cells.
Right. So there's less chance to rectify because you haven't got a memory.
You don't have that backup. They grow faster, so the factor is 2. It's not 1.6.
Wow.
It's faster growth.
Yes. Out of control. It's popularly thought. Yeah.
And this is
Yeah.
I don't think that is so much out of control.
No.
Because I believe that if we change the circumstances in which cancer grows, it will stop growing.
Of course, yes, we understand that. But the majority of people think of it as out of control, random, and unstoppable.
Yeah.
Yeah.
But as we saw it, that there is a different kind of control. And this is more how embryonic growth is happening, because that needs to be much faster. And this is related to metabolism and so forth, and genetic control that is simply different.
So embryonic growth is more towards 2.
Yes, it
doubling.
Seems so. It seems
so. Okay. Something must switch that off then at some point to become more controllable, or
that's basically the first breath of the baby.
Wow.
Because it's related to how the cell utilizes oxygen. It's about fermentation. So cancer cells use fermentation.
Yes, they do.
They don't use oxygen. And embryonic cells, which divide all the time, have their mitochondria switched off and live on fermentation.
So they're very similar.
And the moment the baby starts breathing, there is more oxygen and the mitochondria are switched on.
Yeah, well, that ties in beautifully with what I understand cancerous growth to be, I hadn't thought about it in terms of embryonic growth as well.
It's a different control system. I don't think that it's out of control. It's a different control system, which we need to learn about.
We just don't understand it, so we think of it as out of control.
We know a little bit.
Yeah.
As I said, this is related how the cell metabolism is controlled. Because why would a cancer cell switch from using oxygen to fermentation? This only happens in a toxic environment.
Yes, indeed. It's
when there are too many free radicals.
Yes.
So we could also say the turning of a cell into a cancer cell is protecting itself from being destroyed.
Yes, indeed.
In a very toxic environment.
Yeah.
So let's change the environment.
Exactly.
And there's no need.
Yeah.
For the type of cancer growth. And then it's very often it's hard to find the circumstances that we need to change.
Yes, it is. It isn't easy.
Yeah, and it needs to be done by changing the way we eat, the way we think,
the way we feel,
the way we live.
Yes, yes, yes.
The belief systems, the way we feel.
Yep.
This is how we can heal cancer.
Yes, and that's not how modern medicine views it at all.
Not yet.
Not yet. It's coming in. It's coming in, I know, but it's still seen as an aberration of uncontrollable growth for no reason whatsoever.
Yeah. So I think we could slowly come to an end for today.
Sure, yeah. I mean, that's a beautiful point to finish on. I know we've got lots more we can talk about. But that's so beautifully ties in.
Next time we can use the fundamental fractal and look at a few examples and how we could apply them in our work as therapists.
Oh, great.
That could be interesting.
This is just unbelievably wonderful because it so ties in so many different ideas. Yeah, I'd love to do that. Yeah, let's do that. Well, thank you. As usual, you've blown my mind. You always do.
Yeah. And what I would like to do at the end is just say a few things and give people some opportunities to find more information.
Sure.
Because I always recommend watching the Interscalar YouTube channel.
Yep.
Where Hartmut Müller himself uploaded nice videos where he explains it.
So is that they would just look up Interscalar on YouTube?
Yes. And there's also a website that is called interscalar.com.
Okay.
Where people can find scientific articles.
Yes.
And books about it.
You've written one, of course, as well.
Yeah, I did.
Let's mention it.
Let's mention it, yes. And if we do that, we could also mention our new little myself device.
Yes, why not?
That is now available, which uses electromagnetic pulses, PEMF pulses, to support the natural rhythms of the human bioenergetic electromagnetic body field.
I'd like to get one, actually. I must do that.
Yeah.
So we can post the link.
Yeah, that would be nice.
I'd really like to try it.
And then I think we should find a time for a next talk.
Definitely.
And then we look at the fundamental fractal again.
Brilliant.
Now we know how it is created.
Yes. Yes, extraordinary. Well, Okay, so do you want to tie things up now? And I don't know how you want to edit, but we can just thank you so much, and we'll post links to all of that beneath the video, and then also we'll link into the next video in the series and the previous one as well, so people can follow the chain of what we're doing.
Yeah.
I just want to say, I think what we're doing here is unique. I haven't come across this anywhere else, and so I'm so excited to be doing this with you. It's brilliant.
Yeah. Thank you so much.
All right.
I feel the same, and it's great to do that. Thank you.
All right. Well, thanks very much, and we'll finish the recording.
Yeah. See you next time.
See you next time.